Okay, welcome everyone to this lecture. Okay, as you can see my slide here, this is how the cooling tower work for counterflow and crossflow. This is very the hot topic, exciting topic for everyone. As you can see here, we will talk about what include for this lecture, what is a cooling tower, how the cooling tower work, counterflow versus Crossflow, and then number three, what are two type water distribution type for the headers and sprayers as well. And number four, what are the different type of the fan type? And number five, what's the maintenance availability for the cross and counterflow? And then number six is what is the makeup water for? And then number seven, it's a design consideration when you're picking up these two. Okay. Okay, that's good. So moving on to next one. So let's talk about what is a water cooling tower. So as you can see on the left side of the photo of the cooling tower are used to remove the heat from water using in the water cool application industry. So normally we'll need to working out with the water cool chiller. This usually meaning removing heat from the water cool chillers. You can see a photo of the water cool chiller on the top right of the photo. And then the water cooled chiller usually take the heat from the building. Uh, as you can see, the common heat source at the bottom right of the photo, heat normally coming, most majority coming from the people. So the lights, the plug load, and those are the electrical items plugged into the electrical outlet, and then the solar came through the roof, the wall, and then the windows. A cooling tower use two medium, that is water and the air. The water bring heat from the building, and then we use the ambient air around the cooling tower to absorb the heat and take it away and suck it out through by using the exhaust fan. So let's moving on to the next one to talk more. Okay, so what is a cooling tower types? Counterflow or quartz flow type? So there are two types of cooling tower, counterflow versus crossflow cooling tower. So what's the difference between these two? Normally you will ask for this question. So don't worry about that. So the difference, you look at the how the air enter the filling material. So that's a difference here. So see on the left side of the quartz flow cooling tower, you can see the filling materials in red. Air will um, enter the tower horizontally, and the water will come in trickling down the vertically. So quick recap: air is horizontal and water is vertical. That is a cross flow cooling tower since it is making a cross for the air compared with the water. So now let's go to the right side of the counterflow cooling tower. You can see the filling materials in red, and air is entering the tower through the louvers from the side of the louver and enter vertically up, and then from the bottom going through the filling materials and then straight up as water is trickling down vertically from the top. So that's a counterflow. Okay, so that's good. So I think we're moving on to the next slide. Talk about more about these two types. So you will ask, what are the two water distribution type? So basically, very simple and straightforward. Will be pressurized and gravity. So on the counter flow cooling tower, you can see the photo on the right side. It's a pressurized as hot water coming in here, going through the distribution headers and entering through these nozzles at the sprayers, and then it sprays out over the spread out distributed out over the filling materials. In a cross flow cooling tower, see the photo on the right. it dumped into this hot water basin up here. As you can see, where the green color arrow point at the top of the cooling tower, that's the hot water basin. And then the hot water basin has a little hole in it, and the water will trickle down by gravity through the fill into the cold water basin. So that's a water journey for Crossflow cooling tower. And both type Crossflow and Cross and Counterflow has a cold water basin at the bottom, as you can see, which has a cold water pipe. So cool water is returned to the chillers to pick up the heat, and then from the water cool chiller, and then we're sending the hot water back to the cooling tower. So let's moving on to the next one. So next one, we will talk about two different type of the fan. So build type and direct type. You can see left of the photo. This one here is a direct type in green colors. There's no belt. It's connected directly to the shaft. The motor can be mounted on the inside or outside depending on the configuration of the cooling towers. As you can see the right of the photos, the right side of the photo, this one here is the bell type driven um, bell driven type motors. In you can see in green colors for bell driven. They're showing the inside of the tower. Again, you can also have this mounted on the outside as options. Mounting outside will be a lot of advantage for the maintenance because they can. It's easy for accessibilities and all those. Let's moving on to the next slide. So number five, what's maintenance availability for cross flow and counterflow cooling towers? So this is showing the maintenance ability for two type of different type of the cooling tower counterflow versus crossflow. So you can see left of the photo, left side of the photo for the cross-flow cooling tower. This one here is showing the optional ladders and working platform because the tower is so high, so you need a ladder for service. So this one you can do a maintenance when the system is up and how to do it and then running because the water is actually trickling down here at only the filling section. So there's another section there's no water, so you don't get wet over there. So the maintenance guy can normally can coming through access. You can see on the for the green colors at the right side of the photo. And as there's a walking platform above the cold water basin, so they don't get wet over there. And he can access the tower as it running and access for those fan or those motors or those. And however, if you see on the right side of the photo for the counterflow cooling tower, you can get into the tower totally because all this water is running to be trickling down over basically the whole footprint of the tower. So you will get soaked up until you don't mind, you will get in soak up. But as you can see, access to the motor cannot be from the inside here. So putting the motor outside is extremely important when you have a design considerations. So actually for this case, you need to have actually need to come around the outside or have an access door as opposed to the left one cross flow cooling tower. It's easy access from the inside. So let's move on to the next one. So what is a makeup water? So you ask these questions normally. So basically it's a small amount of water will be lost due to evaporations, blow down and drifted. So for example, evaporation it occurs as the warm water evaporates as it come into contact with the airstream during a cooling process. For blow down, water is bleeding from the cold water basin to reduce the concentration of the salt and other impurities in the circulation water. And for drift, it happens when water is lost as the liquid, basically you just flying away as the liquid droplet that hasn't been evaporated, but they are likely to hijacker riding out of the tower on the airstream, because we don't want to lose this water. So normally the cooling tower vendors will come with the drifted eliminators, as you can see in the green colors on the top right of the photo, install on the top of the tower in order to capture some of those water droplet back, leaving with the airstream. So basically, due to these three reasons, we does lose a chunk of the water. So we need to make up all this water. So basically, we'll need to pipe out with a makeup water line connecting with a cooling tower to bring in additional water every once in a while, periodically, that we lose to the evaporation, blowdown, and drifted. Okay, moving on to next. So this one basically it's the design considerations. This is cooling tower. So cooling tower. So okay, let's talk about this. So number one, design consideration for crossflow and counterflow. So number one will be large footprint for crossflow, but smaller footprint, but taller for counterflow. So cross-flow tower usually take up more area, so larger footprint. So you have the length times the width is much greater for the same tonnage when you compare with the length and the width of the counterflow. And the counterflow is for the same tonnage is going to be a lot taller because of the design configuration. So figure it out when to put the tower. You have to look at the physical area of the space, how many space you got, and then how the air can be moved around through different seasons. Sometimes we need to there may be a blockage coming from south, north side of your sidewalk. So sidewalk is extremely important when you're doing this kind of design. And what wall may be in the way because of the larger footprint of the cross-flow tower. It is operating weight and shipping weight is often more, and you may require additional structural support leg as well. So when you get into, for example, the 800 tons, then this difference can change between the counterflow and cross-flow footprint. That's one of the case. In addition, when getting into big tonnage, normally the length and width remains the same based on my observation, my experience, but the height will increase, but also they will increase those motor or horsepower in order to increase the flow. So you need to get more flow so that they can do more heat exchange basically. And then higher number two will be higher capital cost and maintenance. I would say higher capital cost for cross-flow tower and a lower capital cost for counterflow cooling tower. Since cross-flow require more steel, more structure, and materials, a larger footprint, so it will be definitely more expensive. And then number three, that's a recap maintenance ability for with no downtime for cross-flow tower and downtime for the counterflow cooling towers. So this one you can do maintenance well while the system is up and running because the water is trickling down at only the filling section for the cross flow. Maintenance guy could get through for that, and then basically you have a walking platform above there. You can do the service while it is running. However, you don't have those privilege for cross counterflow cooling towers. Basically, you cannot get into the cooling towers because of the chemical everything. So there's a hazardous concern if you want to get into there. So really, you need to shut down the cooling tower and then do the service. So that's a lot of planning needed to be done, and there definitely will be downtime if you don't have a spare cooling tower or inline spare cooling tower. Then the whole then you don't have your chill water for your plant and all those. So there will be other need to be considered as well. And so this is pretty covered for this lecture, and thank you so much for watching.